The next video has arrived. Okay, we are back and we are going to continue the way we have done until now. I still have not figured out how I want to order this stuff. Again, I'm still pretty bad at LibreOffice. I learned for just a few days ago that this thing had a formula simulator or a formula editor. That was really cool to know. One second, I want to check. Okay, yeah, okay, so our function is something, it seems like it's something f of okay, one second, I'm going to delete the stuff we did last time. The assumption is that our f of x comma y equals something of the likes of x times question mark. And now let's check out the next thing. We're going to check out one g f of 1 comma 0 minus 1. Okay, all right. What about 1 and 1? 0. This seems like an abstract function for now. Now the assumption is that this is going to continue like this, 1 and 2. 1, 2 is 1, alright, 1, 3 is 2. So the assumption is x times y minus x. This is the assumption. So if that assumption is correct, this one should equal 4. So if we input 2, 0, 2, 0 equals minus 4. Okay, yeah, that's the correct one. That was my mistake. Okay, this assumption seems to be pretty working. It seems to be pretty working. Very well, English. Very well. So we need to find x times y minus x. This, first of all, is the same as saying x times y minus x squared. And this might be a useful notation, which is why I'm thinking about writing it like this. So right now we have the equation 666 equals x times y minus y squared. Equals 666 equals x times y minus y squared, x minus x squared. And this means this is equivalent to the idea of x squared minus x times y plus 666 equals 0. And with that I'm going to do some basic calculations. I'm just going to input a form. I'm going to calculate the formula for this thing, so 1 second. Okay, I think this is the function, the formula that we're looking for. X equals y squared half plus the square root of minus 666 plus y squared divided by 4. And we are going to solve this the same way that we solved it last time. I'm going to just slightly adjust this. Okay, so we are going to I'm going to first of all change this one back to mostly its original size, like this maybe. And now we're going to, this is our y and this is our f of y. I don't know what's going on with, one day I will find out. Y and f of y. Let's go for, at what point should we start? I think that this isn't the smartest point to start off. Let's go for 40, no, maybe 30. 900, no, that's too little. 1600, 800, 400, still too little. 2500, let's go for 40. And we are going to go for 41. We're going to go up to 66. And now this one equals minus this one divided by 2 plus the square root of this one squared divided by 4 minus 666. And I'm going to do this for all of those. And I definitely made a mistake at some point. Minus this one plus the square root of minus 666. Maybe like this. Still didn't fix it. Yeah, this is what I wrote. 40 square is 1600. Divided by 4 is not... Okay, yeah. Minus 666. First of all, let's think about this. Maybe I made some errors with the parentheses. Minus 666. Okay, I think like this should be better. Next I'm going to drag this down, and right here we have the first numbers. Okay, now we have something. Okay, and we got our output. So the reason why this one is an error is because all those numbers are probably negative because or are imaginary, which is what I expected. So this one should be a working one. So we need to input minus 18 and 55. Okay. That's not good. I just noticed 55 doesn't work. Do we have an easy solution on how to get to 55? Oh, that's annoying. Do we have another one? Okay, I think I do have to. Okay, we're going to continue like this, and maybe, yeah. We have another one, 83 and minus 1, minus 9. This one works, okay. 9 minus 83. It doesn't work. Why does it not work? It either is the case that I miscalculated or that I wrote something down that is wrong. So let's think about this. F of... Okay, we're going to write like this. F of x1 equals f of minus 9.83. Okay. Maybe I need to go higher, and we have a problem with this one not recognizing minus 9 the way that I wanted to. I could do that, but it would be so I think it would be annoying, which is why I don't want to do that. You know what, we're going to first of all continue a little bit. Who knows, maybe we are getting some numbers down the line and I don't have to think. That could work. I just need to find something that works. Oh, and we have another one, minus 6. Okay, we're getting into the right direction. Let's go down some more. We are getting slowly. We're growing. We are growing, which is good. I just need to go high enough, and then we will at some point have numbers which are higher than 0, I guess. Yeah. And like that, we are at what point? Whoop. Okay. Can you actually still see everything? Yeah, you can. Okay. Yeah, let's just continue like this. We are getting closer. This function is a little bit slow because it's a root function, but the root function diverges to infinity, which is why we can do that. We will at some point find the numbers we are searching for, if everything I think is correct. But the root function converges slower and diverges slower and slower, which is why it's taking so long to find decent things. If this doesn't work, I actually have to think, which is what I'm trying to avoid right now. Right now I am trying to solve the entire equation by finding an equationary rule for my x and y, and then trying to to write a table containing all the possible solutions for x and y, and then just trying to find the ones that I can input right here and then inputting them. But this is too... We're going to go for 2000, I think. Let's go for... Yeah, we need to go down deep. We need to go down really deep. If I don't see any appropriate function, then I have to do another different equation maybe. It's a possibility that I don't want to do if I don't need to. I think solving after y might be easier, which is what I'm thinking of right now. But it would mean that I need to redo this entire equationary thing that I had going. So I don't really feel like it, to be honest. And we have... okay, this is taking way too long. I went for until... okay, we need to do this a different way. I thought we could do this an interesting way, a lazy way, but still an interesting way. I'm going to instead solve for y. Okay. 666 equals x times y minus x. I think like this. What? Why is there a square symbol right there? X times y minus x squared. I honestly, it's been so long that I forgot why. Really quick, wait a second. 1, 4. Oh yeah, okay, I get it. Yeah. This is correct, okay. Equals, okay, so x times y minus x would mean 666 divided by x equals y minus x. So we are going to go for y equals 666 divided by x plus x. And this means we are going to delete those things. We're also going to delete, this one is fine, x, y. We're going to write this one starting from 0. Maybe starting from 0 is not the best idea. Let's go for starting from 1. Let's go for maybe 150. Then maybe this should be fine. Okay, 150. Let's make it nice and round. And this one, x, y equals 666 divided by this right here. Okay. Divide. Okay, now this is interesting. I don't know how to divide in this one. Divide returns the quotient of two complex numbers. Okay, we need to have this one imdiv. Imaginary equals imdiv of the first one, the numerator, which would be 666, and the denominator, which would be this tile right here. And we are going to add on top of that this tile right here. Okay, 1 and 667 would work. We need to enlarge this. Okay, I think I didn't even need this many. Maybe I need this many. Let's go for like this, and we have some options. We can go for 3, 3, 5 and 2. Doesn't work. 3 and 225 also doesn't work. 4 and 170.5 doesn't work. 5 doesn't work. 6 and 117 doesn't work. This one doesn't work. 9 and 83. Okay. And that is how easy you can solve this equation, and I could have stopped long ago, But hey, you learn. I didn't know. Did you learn something? I just I just created a table, and then I created an equation 666 equals, and I input the equation, the function, the rule of the function, how we output something basically. Then I solved for one of the variables, and I plotted the variables over each other. No, I didn't plot them. I put them in a table next to each other basically, and then I searched for one pair of variables that had the correct, the needed parameters to be inputted. Just out of curiosity. Okay. Okay. Yeah, this function seems very similar to what we have already seen. 2 to 0. Infinity, okay. Okay. 4 divided by 0 should be 2. Okay. 8888 divided by 8 should be 1111. God damn. Okay. It's a little more complicated than I would have wanted to. Let's check once more. 5 divided by 0, it's 2.2. Okay, it's not that easy. Okay, okay, okay. And I'm hungry. 1 second. Okay, I changed the layout of this entire thing a little bit, which should make it easier in theory to, you know, to have. I just cleared some things and I wrote them again. It's nothing special. And those lines, I guess, symbolize that we can't input that function. In this case, 0, 1, it was just a little too easy to understand that 0, f of 0, 1 would be 0, so I just wrote it into this. We're going to have to fill those out later if we want to, but for now we're going to continue at 2, f of 2, 2. Okay, this seems like the square root of 2. Square root of 2. And if that is the case, then f of 8, 3 could be 2. Okay, okay. Okay, the assumption that I have right now, f of x, comma y, equals the nth, no, the yth root of x. And if that is the case, then we need to do. Okay, okay, we're going to need to. Okay. Okay, yeah, well, I think we can do this. I just had to think a little bit about this. So we're not going to do it like that, okay. We're going to plot something again. Not plot. Again, I'm saying plot in the wrong way. Okay, this is 666, and how do I do this the best way? 1. I can do this, and then equals 666 to the power of this square to this square. And now this should work. 443556. 443556 and 2. It's as easy as that. I just had to input that. I could have also gone for this one, I think, because this whatever, it doesn't matter. It does not matter. Level 27. I also need to think. I'm just going to, yeah, okay, we're just going to do this. 0, 0, okay, 0, 1, okay, 0, 2, okay, 0, 3, 0, 4. Okay, we have some things to do. Okay, this one had an increase of 1, this one of 2, no, this one was 3, and this one was 6, and this one was 10. Oh, the next one would have been 10. This is basically if you sum up all the numbers from 0, all the first 4 numbers, you would get that. I don't know if that has any relevancy for now. Okay, we're going to look further before we do any thinking. 1, 0 is 1. 1, 1 is 1, okay. 1, 2 is not 2, right? It's 3, okay. 1 to 4 would be 10, okay. 1, 1, 3, and I'm assuming this is 1, 1. Oops, I made some small mistake. 1, 0 was 1, 1, 1 was 1, 1, 2 was 3, okay, and 1, 3 was... 1 second, 1, 3 was 6, yeah, okay. Yeah, okay, my small mistake. And the assumption is that this is 1, 1, 1, 3. And let's try this. 2, 0 was... okay, I'm confused. Alright, alright. We're going to continue, first of all, we're going to continue with the 0. I need to go a little larger than I have until now. 10. What happens now? 15? Okay. What happens now? 28. 36. And this is working the way that I think it works. So right now, for f of 0, it works this way. F of x, y equals the sum of from I equals 0 to I equals y. This is what it looks like. If we go if we start from 1, however, we start at 1. Then we go to 3. Oh, what? Okay, 6. Okay, maybe I just had a small mistake. 0, 0 was 0, correct? Yeah, okay. 1, 3, 6. Okay, then I made a small mistake. Okay, my mistake. 1, 0, 1, 3, 6. So this one is still a 1, 3, 6 and a 10, if everything is correct with my assumption right now. This is a 3, 6, 10 and a 15. This is a 6, 10, 15, 21. Alright, then we need to go for... Okay, we're first of all going to check out... We're going to do another table, and I don't know how to input this properly, but I never knew from any of the other ones. So we're starting at 1, and we're expanding. Okay. How do I do this the best way? This one equals the sum of E the 1 to E dollar. I think I need to use a dollar sign. E dollar 1 to E 1, if I'm correct. Now I am expanding this thing. Okay, it works. Okay. The dollar makes it so that if I expand this downwards, this one does not move, which is what I have been hoping for, which would happen. Okay, we just expand this a little more. 42 maybe. And 666. I just need to input the 37. Alright. 0, 37 maybe, I'm too lazy to think. 2, 34, 2, 35. I really don't want to think, so I'm just ignoring what I should be doing, but I think I need to now think. 29, 5, 37, 437, 337. Okay, I need to think about this, it's fine. So this one, if I just have a sum like that, I think it's fine. If I input 037, I get a 703. If I input a 137, I get a 703. What? 0 37, I get a 703. Okay, 137, I get a 703. 237, 702. 337, 700. I am basically subtracting those things from them. Okay, 1037, too high, too low. Okay, 937. Okay, 837. I think I understand this now. So basically, the lower parts of this thing are the first number says where we start, and the second number says where we end. So I do need to start at 0, I think. 37, 0, 35. And right here I have a critical thinking error. Let's think about this. 1, 0, 1, 3. Let's go back to the beginning. 0, 0 is a 0. 0, 1 is a 1. 0, 2 is a 3. Okay, this works. 0, 1, 3. I can just input a 0 right here just to make this a little easier. And I'm just going to delete this one. Okay. The 666 is a part of this sum notation. So what I would have expected would be the 37th sum of this thing, if I input 0 and 37, would be exactly that. But how far are we apart? We are apart 666, so 37 exactly. And why are we apart 37 exactly? Please do not tell me what I think is happening. Let's go for 35 for a quick second. And if this is what I think it is, I should get 630. Yeah, I don't care about that. 667. 037 was a 675. No, it wasn't. It was 037. 703. Yeah. 137 I can't do. So the first thing we notice is that 666 is right here, so the thing right now we are one off, so if I inputted 36, this will work. I think I need to do the following. I need to do another value equals this right here minus this right here. Then I scroll it down like that. Okay. Right here, if I input 3... No, okay, I need to go for those parts. The number that I could go for is 36, so for example, right here, 666 and 36. So 36 as the 9th one. So if I start at 9 and 37, yeah, this works. If I start at 9 and 37 and 36, I would have gotten it. So, alright, I have an idea on how this works. It's a little hard to explain, let's think about this. So right here I look into the numbers, this is the differences that we grow from this one to, from each sum to each other. So we grow from this one to this one, 14 and 15, which is logical because this is a sum from all numbers that came before before the one that we're looking at. So do we not change anything? So what I have tried to do was look into this difference and try to subtract enough that if I inputted a 37, I really can't explain it. This is not the best way to explain it. 700. Okay, we're going to do this maybe a little differently. So 0.37 we can't go for. What about 0.38? 741. 38 and 37. We're going to do another line. This one is going to be equals 666 minus this one, I think. And we're going to expand this one again. Now we look at not the difference between each sum that we're looking at in ascending order. We're looking at the difference between the 666 and any other thing. This should make things easier. It just makes things a little more confusing because there are more numbers on the field, on the screen. 170 right here, this one is interesting. So if we go for this is 170 minus, is it not? We need to change this rule. Okay, yeah, whatever, we can keep them. The important one is that we check. Okay, 327 is that a thing? I'm going to color this one as the important one. I'm going to color it green. And this one is also important. This is the one that we are also looking at right now. Blue. I'm sorry if you don't like that color, it's a little too bad. Ah, yeah, you know what, we're gonna go for another one. Custom color, maybe light blue. Yeah, better. It's better than before. So right here, minus 37. 37 we just tried. No, we didn't try that one. Minus 75. What? Why is this one? Okay. No, it's... I think I made a small mistake. We're going to try this one again. So this one equals... this right here, minus 666. And we're going to spread this one down again. And we now have a little better stuff. Okay, now it's in the right order. 75 isn't an option. 114 is also not an option. 154. Also not quite, but this is almost the thing we can use. So if we try out the 40s, we can maybe get something. 040 is 820. Okay. And now 40 is the which what? Not for, okay, 154. So if we go for 1840 maybe. Okay. And I will eat something after I'm finished with this one. I'm getting hungry. 1740. 1940. Please? Okay, yeah, this doesn't work. I need to have an exact number. I'm going to search for the exact number and we will see each other in a second. Well, I have to be honest, and to be honest, I haven't yet found out how to solve this. I have looked at this for a few minutes and currently I have no idea. So my suggestion is that we are going to continue this another day. I have also tried a few different things that haven't worked. I do think that I am somewhat close to the solution, and if I have a solution, well, I can't really prove that I haven't thought of it myself, that I have thought of it myself, but I will have thought of it by myself by using LibreOffice, and I will talk about the solution the next time we see each other in the Devil's Calculator. So, have a nice day and goodbye.